So this is a problem asked in JEE Advanced 2007, and the problem says let x, y be the ordered pair such that sine inverse of ax plus cos inverse of y plus cos inverse of bxy is equals to pi by 2. Then we have to match these two columns as per the values of a and b. So here it is given that sine inverse of ax plus cos inverse of y plus cos inverse of bxy is equals to pi by 2. So what I'll do, I'll bring this cos sine inverse of ax that side, and we can write here as minus sine inverse of ax. And we already know that the sine inverse of x plus cos inverse of x is equals to pi by 2. So we can replace this pi by 2 minus sine inverse of ax as cos inverse of ax. So we can write this as cos inverse of ax. Now we'll assume, let's say, this angle cos inverse of y, let's say this is alpha, this I'll assume is a beta, and this I take as a gamma angle. So as cos inverse of y I have taken as alpha, so we can write cos alpha's value is y. Similarly, we will get cos beta's value is equals to bxy, and cos gamma's value will get ax. So we can write that gamma minus alpha is equals to beta. And then we can write cos gamma minus alpha is equals to cos beta. So we just open the cos formula, we apply that cos gamma cos alpha plus sin alpha sin gamma is equals to cos beta. So we can substitute those values. Cos gamma's value is ax, cos alpha's value is y, so axy. Sin alpha and sin gamma we don't know, so sin alpha and sin gamma as of now we are leaving, and cos beta's value is bxy. So we can write sin alpha sin gamma is equals to bxy minus axy, where we can take xy common, we'll get b minus a. So take xy common, we'll get b minus a. Now squaring both the sides. Why am I squaring? Because after squaring, sin square alpha can easily be converted in cos square alpha, and similarly sin square gamma. And those values of cos alpha and cos gamma we already know. This is the cos alpha, cos gamma value we know. So squaring this one, this equation, let's say this I take as a 1, squaring both the side will get sin square alpha into sin square gamma is equals to a minus b whole square x square y square. Sin square alpha can be written as a 1 minus cos square alpha, and cos square alpha's value is y. So cos square alpha will become y square, and sin square gamma we can write 1 minus cos square gamma, and cos square gamma's value is ax. So cos square gamma will become 1 minus a square x square is equals to a minus b square x square minus y square. This is what you will get there. Now we can verify each of the option by substituting the values. In the first it is given a is equals to 1 and b equals to 0. So if I write a is equals to 1 there and b equals to 0 there, a equals to 1 and b equals to 0. So we get 1 minus y square, 1 minus x square is equals to x square y square. So if I open the bracket here, further we simplify, I'll get 1 minus y square minus x square plus x square y square is equals to x square y square. X square y square is cancelled, and I'll get x square plus y square is equals to 1. So you can match this one after taking A, we can match to P. and then we will write the values there. In the second b, we have to keep a equals to 1 and b equals to 1. So we'll write a equals to 1 and b equals to 1 this side. So that will entire part this side will become 0, and we'll get 1 minus y square into 1 minus x square is equals to 0. So we'll check the option. See this one, these two options are same. You can take the minus common in both the brackets, and so we'll get. Then a equals to 1 and b is equals to 2. So if I write a is equals to, this is match with q. And when you write a is equals to 1, we get 1 minus y square, 1 minus y square, and then we'll get 1 minus x square, and a is equals to 1 and b is equals to 2. So a equals to 1 and b equals to 2 will give minus x square y square that side. So we get b equals to 2, we have substituted here, a equals to 1 there. So we'll get 1 minus y square into 1 minus x square is equals to plus, that will be plus there, x square y square, because this minus 1's square you have to do it, so that will become plus. So this is again the same option with the p you will get as I have done it here. And then again you can write a equals to 2 and b equals to 2. So if I write a equals to 2, b equals to 2, this part will become 0. And if it is 0, and then you write a is equals to 2, that will become 4. So 4x square minus 1, this part you will get. So I hope it is clear, and see how easy problems they ask in the JEE Advanced. So now it's a JEE Advanced 2013 problem. So here the P and S are the problem from inverse trigonometry, and these two problems are from basic trigonometric operations. So you can see it is given 1 upon y square cos of tan inverse of y plus y of sine of tan inverse of y upon cot of sine inverse of y plus tan of sine inverse of y. So we can convert those values. You can easily, very easily you can simplify it. So first you see this, if we draw a triangle there, and this angle I take as a theta there. So in first you can see that the tan inverse of y's value is given as a theta. So tan theta is equals to y. So if I have taken tan theta is equals to y, this is 1, and this will get under root of 1 plus y square. And from there I can convert the tan inverse, whether can be converted, tan inverse of y can be written as a cos inverse of 1 upon under root of 1 plus y square. So once I substitute this tan inverse of y as a cos inverse of 1 upon under root of 1 plus y square, that automatically becomes, so I'm writing just the simple form, cos of, see here, cos of cos inverse of 1 upon under root of 1 plus y square, that will be 1 upon under root of 1 plus y square. As we already know that the f of f inverse of x is equals to x. So we'll get the first term will become 1 upon under root of 1 plus y square. Similarly, we'll substitute sine of tan inverse of y is there. So sine of tan inverse of y. So again you see you can convert that sine of tan inverse of y. So you have the value of tan theta, and from there you can get the value of sine theta. So this I take as a theta, it's tan inverse of y is equals to theta, tan theta is equals to y. So this is y, this is 1, this is under root of 1 plus y square. So you see that the sine theta's value is y upon under root of 1 plus y square. So theta can be written as a sine inverse of y upon under root of 1 plus y square. So this tan inverse will replace by sine inverse, and this can be written as a sine of sine inverse of y upon under root of 1 plus y square. So that will become y upon under root of 1 plus y square. And 1y is already there before, you can see. So y square upon under root of 1 plus y square will get. So simplify y square upon under root of 1 plus y square. So this numerator we can further simplify it. You can see there under root of 1 plus y square will come in the denominator and 1 plus y square will come in the numerator, and that can be written as under root of 1 plus y square. So I hope this point is clear. See, you can see here, this is common there. So 1 plus y square you will get in the numerator, under root of 1 plus y square will be there, and numerators under root of 1 plus y square and 1 in the denominator you can cancel and you will get there. So basically that numerator becomes under root of 1 plus y square after simplification. Now we'll simplify this quad of sine inverse of y. So similarly we can simplify this quad of sine inverse of y also. So draw a triangle. Let's say this angle is theta. Now you have sine theta's value is y, as I have taken sine inverse is equal sine inverse of y equals to theta. So sine theta is equals to y. So this is y, this is 1. It is under root of 1 minus y square. So cot theta will become under root of 1 minus y square divided by y. So theta is equals to cot inverse of under root of 1 minus y square upon y. And further we can substitute the value. So you simplify cot inverse of under root of 1 minus y square upon y, which will become under root of 1 minus y square upon y. So this sine inverse we have converted in cot inverse and we got the result this. So this is under root of 1 minus y square divided by y plus, now we'll simplify tan of sine inverse. You can see there. It is tan of sine inverse of y. So we can simplify this also. So in this you can see that the sine inverse of y will take sine inverse of y is equals to theta. Again sine theta is equals to y. So sine theta is y. This is 1. Hypotenuse perpendicular is y. So it is under root of 1 minus y square. So tan theta is equals to y upon under root of 1 minus y square. So theta is equals to tan inverse of y upon under root of 1 minus y square. So tan inverse of y upon under root of 1 minus y square can be written as a y upon under root of 1 minus y square. So I can replace this entire value by y upon under root of 1 minus y square. After the square, then plus y raised to the power 4 and the whole power 1 by 2. So now you see there, if you simplify it now, so you can see it will, if I simplify now the denominator there, you will get 1 minus y square plus y square divided by y into under root of 1 minus y square. I just took the LCM there in the denominator, and this is y square cancel, and so we'll get under root of 1 plus y square divided by 1 upon y into under root of 1 minus y square, and this whole square, there is a pre-multiplication of 1 by y square plus y raised to the power 4 to the whole power 1 by 2. So if I simplify it, we'll bring it in the numerator there. So you can see this is a y square. This y is given in the denominator. So it will get cancelled. This square is there. And the numerator you will get, this will come in the numerator there. And this will become under root of 1 plus y square into under root of 1 minus y square whole square. So we'll get 1 minus y raised to the power 4. And plus y raised to the power 4 to the whole power 1 by 2. So y square cancel, 1 is the answer. So from there we can get the answer now. So this is a basically, this is a question from the trigonometry. Cos y, cos x plus cos y plus cos z is equals to 0. Sin x plus sin y plus sin z is also 0. Then we have to get the value of cos of x minus y. See, this problem we can solve very easily, and I'll just give you the hint how we can solve this problem. You can write this cos x plus cos y . So this is given that cos x plus cos y plus cos z is equal to 0. So what we can do here, we can write cos x plus cos y is equals to minus cos z. And similarly we can write sin x plus sin y is equals to minus sin z. And then squaring both the side, if I square it this side and square it this side, both the side is square it and add. So when you square and add, you will get cos square x plus cos square y plus 2 cos x cos y plus sin square x plus sin square y plus 2 sin x sin y is equals to cos square z plus sin square z. So you can see the cos square x plus sin square x will become 1. This cos square y plus sin square plus y equals to 1. And this side cos square z plus sin square z will also become 1. So we get this 2 plus 2. Here we'll use the formula of cos A cos B plus sin A sin B. So we'll get 2 cos of x minus y is equals to 1. So then you can convert the cos 2 theta formula we can use. You can, that the cos 2 theta can be written as a 2 cos square theta minus 1. So if I take 2 theta is equals to x minus y, so cos of x minus y's value is 2 into cos square of x minus y by 2 minus 1. So we can now substitute that value of cos of x minus y and we can verify it. And then we can come to this part, the r part of this one. So it is cos of pi by 4 minus x, and it is given cos of pi by 4 minus x into cos 2x plus sin x sin 2 sec x cos x and sin 2x. So this is sin x into sin 2x. So this we'll check further because I think there's something is missing there. Sin of 2 sec x must not be there. So I'll tell you this thing in the next lecture, and I'll come to this s part. This is cot of sin inverse of under root of 1 minus x square is equals to sin of tan inverse of x root 6, and x is not equals to 0. Then the possible value of x we have to get. So sin inverse of under root of 1 minus x square is given. We just convert in the cot. The sin inverse's value is given. So this is under root of 1 minus x square. This is 1. So if I simplify, I'll get this value is x. This I have taken sin inverse of under root of 1 minus x square is equals to theta. So sine theta is equals to under root of 1 minus x square. So from there we get the value of cot theta. So cot theta will be x divided by under root of 1 minus x square. So we can write here cot inverse of x divided by under root of 1 minus x square is equals to sine of this tan inverse of x root 6 we can convert. So this you can easily, tan theta is x root 6. So this is x root 6. This is 1 we'll get. And we'll square it. So we'll get 6x square plus 1 square root. So we can find the value of sine theta. So sine theta value is x root 6 upon under root of 1 plus 6x square. So we can substitute that value of theta as value of sine in terms of sine inverse. So we'll get sine inverse of x root 6 divided by under root of 1 plus 6x square. So now we can simplify it. So cot and cot inverse are cancelled there. Here sine and sine inverse of cancel there. And so you get x upon under root of 1 minus x square is equals to x root 6 upon under root of 1 plus 6x square. So now you can simplify it and get the result. It's quite easy there. It's given that x is not equal to 0. So you can cancel that part of x and cross multiply and you can find the value of x there. So now we come to the few problems asked in this JEE Mains. So you can see the first problem is asked in 2002 JEE Mains. Cot inverse of under root of cos alpha minus tan inverse of under root of cos alpha is equals to x. Then sin x's value we have to find. So here you can see it's a tan inverse. We can write 1 upon under root of cos alpha minus tan inverse of under root of cos alpha, and this is equals to x. So we can use the formula of tan inverse of x minus tan inverse of y. The conditions I have already explained in the last lecture. So you can just revise that lecture. You can directly use that formula. So you'll get tan inverse of 1 upon under root of cos alpha minus under root of cos alpha divided by tan inverse of x minus y upon 1 plus xy. So 1 plus xy, when we are doing under root of cos alpha, you'll see that 1 plus under root of cos alpha into under root of cos alpha, these are cancelled. So it will become tan inverse of 1 minus cos alpha and divided by 2 under root of cos alpha, and this is equals to x. So we can see that if we write that tan x is equals to 1 minus cos alpha upon 2 under root of cos alpha. Now what I'll do is just simplify these values. So you say that tan x's value is given. So we can write that cot x is equals to 2 under root of cos alpha upon 1 minus cos alpha. So we can just take the componendo dividendo we can apply, otherwise you can simply simplify it. So we can get the sin x's value. See here the cot x's value is given, that is cos x upon sin x's value is given, and from there you have the value of sin x plus cos x value is also given. So if you simplify it, you will get sin x's value is equals to 1 minus cos alpha upon 1 plus cos alpha. So from there if I simplify, it is 1 minus 2 sin square alpha by 2 divided by 1 plus 2 cos square alpha by 2 minus 1. So this 1 and 1 and this 1 and 1 are cancelled, and that will become tan square alpha by 2. So you can see A option is correct there. So now we come to the second question. So second question is the trigonometric equation sine inverse of x is equal to 2 sine inverse of A has a solution for. See, this sine inverse of x's answer you will always get from minus pi by 2 to plus pi by 2. But this side you can have the total answers between minus pi to plus pi. Because sine inverse of A's answer will get minus pi by 2 to plus pi by 2, and then 2 sine inverse of A's answer will become between minus pi to plus pi. So we'll have to restrict A between, so that we get 2 sine inverse of A must remain pi by 2 minus pi by 2 to plus pi by 2. Or we can write 2, we can remove and we can write here pi by 4. This side, this pi by 4, this is pi by 4. So that means A mod A's value will have to keep less than or equals to 1 by root 2. So D option is correct here. They have not included, but we can also include that value also. Now we come to the next question. This was asked in 2005 and the problem is cos inverse of x minus cos inverse of y by 2 is equals to alpha. Then 4x square minus 4xy plus y square is equals to. So we'll simplify and then from there we can find the value. The cos inverse of x minus cos inverse of y by 2 is equals to A. So we know that the cos of alpha minus beta is equals to cos alpha into cos beta plus sin alpha into sin beta. So if I take cos alpha is equals to x, we can write alpha is equals to cos inverse of x. And if we take cos beta is equals to y, this formula I am deriving you, and beta is equals to cos inverse of y. So we can write alpha minus beta is equals to cos inverse of cos alpha cos beta plus sin alpha sin beta. So that means cos inverse of x minus cos inverse of y can be written as a cos inverse of xy plus sin alpha can be written as a under root of 1 minus x square and sin beta can be written as a under root of 1 minus y square. So this is what we can use here. So we'll get cos inverse of xy by 2 plus under root of 1 minus x square into 1 minus y square by 4 and is equals to alpha. Okay, so now the cos alpha's value will get xy plus 2, you can write it, will take common and multiply other side after taking the LCM. So under root of will get 4 and this will get 4 minus, so I have taken that LCM also there and I took that 4 outside the square root and multiplied other side. Once you get this side cos inverse, I multiplied this side. So 2 cos alpha is equals to xy plus 4 minus y square minus 4x square plus x square y square. So now this we can write that so basically we have to get the value of 4 minus 4x square minus 4xy, this value 4xy cos alpha plus y square. This value we have to find it. Okay, so you can see this is x plus y, and this you bring it other side, you write 2 cos alpha minus xy and square it. And this side will also get 4 minus, there you can see 4 minus y square minus 4x square plus x square y square. So you can simplify it, and from there you can conclude the answer. Now we come to the next question, that is sine inverse of x by 5 plus cosecant inverse of 5 by 4 is equals to pi by 2. Then the value of x. It's a very easy problem. You can see sine inverse of x by 5 plus cosec inverse of 4 by 5. So what you can do here is sine inverse of x by 5. You can write equals to pi by 2 minus cosec inverse of 5 by 4. And then you can write pi by 2 minus sine inverse of 4 by 5. That is sine inverse of x by 5. So pi by 2 minus sine inverse of 4 by 5 will become cos inverse of 4 by 5, and this is what the value of sine inverse of x by 5. So now cos inverse of 4 by 5 we can convert. This is 4, this is 5, this is 3. If I take this angle is equals to theta. So that sine inverse of 3 by 5 it can be written. So sine inverse of x by 5 is equals to sine inverse of 3 by 5. So x's value is 3. So we come to the next question now. That is the value of cot of cosec inverse of 3 by 5 plus tan inverse of 2 by 3. Cot of cosec inverse of 3 by 5 plus tan inverse of 2 by 3 is very easy. You can convert that cosec inverse of 5 by 3. Draw the triangle there. So cosec theta's value is 5 by 3. Cosec theta's value is 5 by 3. So this is your 5. This is 3. So this will become 4. So, and the tan inverse of 2 by 3 is given. So we'll convert in tan, and we can write this much. We can write as a tan inverse of 3 by 4 plus tan inverse of 2 by 3. So you can, now it's a quite easy problem. You use the formula of tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y upon 1 minus xy. So be careful while checking the formula whether anything you have to add or subtract there. So you can see x into y, 3 by 4 into 2 by 3. So this is half, which is less than 1. So directly this is less than 1. X into y's value you can see. So we can directly use the formula, and you can further solve it now. So we now come to the next question, that is question number 6. JEE Mains 2013. So this question is this x, y, z are in AP, and tan inverse x, tan inverse y, and tan inverse z are also in AP. Then we have to find this. So it is given that x, y, z are in AP. So we can write 2y is equals to x plus z. And it is also given that the tan inverse of x, tan inverse of y, and tan inverse of z are AP. So we can write 2 tan inverse of y is equal to tan inverse of x plus tan inverse of z. So this you can write tan inverse, 2 tan inverse of y can be written as a tan inverse of 2y upon 1 minus y square. And this tan inverse of x plus tan inverse of z can be written as a tan inverse of x plus z upon 1 minus xz. So this, if you simplify, you get x plus z upon 1 minus xz is equals to, this you will get 2y upon 1 minus y square. Now you can see that we have the 2y's value is x plus z, so we can replace. Otherwise we can cancel it out. Just by taking one side you cancel. I'm just writing it. Otherwise it's not advisable to do it. Just bring it one side and take the common there. So now we'll see that cross multiply 1 minus y square is equals to 1 minus xz. So 1 and 1 are cancelled. So we'll get y square is equals to xz. So y square is equals to xz we get, and then what we have to then, so from there we can conclude that x is equals to y is equals to z there, because this is the possibility there we can have. And so this last problem, it was asked in 2015. So this is a tan inverse of y is equal to tan inverse of x plus tan inverse of 2x upon 1 minus x square. So we can write this as a tan inverse of x plus tan inverse of 2x upon 1 minus x square. So this we can write, I explained in the last lecture that this can be written as a 2 tan inverse of x. So in total you will get 3 tan inverse of x. So 3 tan inverse of x, we can write tan inverse of y. Just use the formula of tan theta, and from there you can conclude the value of 3 tan inverse of x, which is 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. So 3 tan inverse x can be written as a tan inverse of 3x minus x cube upon 1 minus 3x square. Now you see that the mod x's value is given is less than 1 by root 3. So you can see when I'm taking mod x's value is less than 1 by root 3, that means x I'm keeping between minus 1 by root 3 to plus 1 by root 3. Between means minus pi by 6 to plus pi by 6. So even if I multiply 3, so I'll get the value between minus pi by 2 to plus pi by 2. 3 into minus pi by 6, you can see 3 into plus pi by 6, you'll get this minus pi by 2 and plus pi by 2. So using this formula directly, there is no harm in using this formula directly over there. So now we can see what we have to, then the value of y we have to, so 3x minus x cube upon 1 minus 3x square, 3x minus x cube upon 1 minus 3x. So C option is correct. Thank you. Rest of the problems I will be doing in the next lecture.